We're going to solve the equation 5 to the x minus 40 times 5 to the minus x plus 3 equals 0. What we remember is that 5 to the minus x is just 1 over 5 to the x. When we have a negative exponent, the only thing it does is move things across the fraction bar. So we have 5 to the x minus 40 times 1 over 5 to the x plus 3 equals 0. Now, in order to solve this, we will want to clear the fractions. So our lowest common denominator of all terms is 5 to the x. So we'll multiply both sides by 5 to the x. So we'll have 5 to the x times 5 to the x minus 40 times 1 over 5 to the x plus 3 equals, and then we'll multiply the right side by 5 to the x also. When we do this, we're going to distribute 5 to the x over these three terms. So we'll wind up with 5 to the x times 5 to the x minus 40 times 1 over 5 to the x times 5 to the x plus 3 times 5 to the x, and we still have 0 on the right. Now, when we multiply with like bases, we would add exponents. So we have 5 to the 2x, x plus x, minus 40, because these 5 to the x's are going to cancel, plus 3 times 5 to the x equals 0. Now we can rewrite this so that we have descending order. So we would have 5 to the 2x plus 3 times 5 to the x minus 40 equals 0. So now we will want to factor this. And this will factor as 5 to the x and 5 to the x. Just like we're factoring a quadratic. We have to think of numbers that will multiply to get negative 40 and add to get positive 3, and that will be plus 8 and minus 5. Now we can set each one equal to 0. 5 to the x plus 8 is 0, or 5 to the x minus 5 is 0. This would give us 5 to the x equals negative 8. But that is impossible because we can't take a positive number, raise it to a power, and wind up with a negative number. So we don't get a solution there. The other is 5 to the x equals 5. And in that case, x would be equal to 1.